Homework Hotline, what is your emergency?
Hello and welcome to Homework Hotline. Thank you for joining us. My name is Becca and I'm a math teacher at Emily Griffith High School.
That's odd. I'm also a math teacher at Emily Griffith High School. I think I've seen you around actually. My name is Nathan.
I don't know. Well, are you stuck on a math problem? Well, that's why we're here. We'll help you work through the problem so that you can better understand how to get to the answer.
We're here every Tuesday and Wednesday from 4:30 to 5:30 p.m. You can give us a call at 720-424-1666. Giving us a call allows us to help you, or allows us to answer your questions a little bit more thoroughly.
You can watch our show in several different ways. You can tune into Comcast Channel 22, go to livestream.com and search for EG Homework Hotline, or watch us on YouTube by searching for DPS TV Homework Hotline.
The Homework Hotline is sponsored by Emily Griffith High School. Becca and I aren't the only ones here representing this school. Lily is also a student at Emily Griffith High School. Tell us a little bit about yourself.
Hi guys, I'm Lily. I help get your questions in social media, email, and text over to Becca and Nathan to help them answer your questions. And so at the top of each show, I will have a trivia question, and before the end of the show, I want to hear the answer from you. And today we have a math question, and can we stump our math teachers? And so today, our question is, what are the chances that in a room of 75 people that at least two of them would share the same birthday? Let's prove your superior intellect.
All right, thank you, Lily. Well, actually, let's get you our contact information so that you know how to call in and get your questions to us. You can see the phone number on the top half of your screen, or the top right of your screen right now, as Nathan gave it to you earlier, but you can also contact us in other ways. You can get a hold of us via social media if you'd like, at EG Homework. You can text us if you want at 970-680-3771. Or if you'd like, you can even email us at homework@emilygriffith.edu. So those are all of the ways that you can get in contact with us. Just give us a call, ask your homework question, and we're here to help you. So in the meantime, let's go to social media with Lily and answer some of the questions that have been left up there.
Okay, so the first question for today is, the height of a triangle is 4 and more than 2 times length of base. Area is 35 inches squared. What is the height of the triangle?
Okay, I can take that geometry question. So this is actually a geometry question, and it's also a systems of equations question. So I think the tricky part of these, we said the height of the triangle is 4 inches more than 2 times the length of its base. And the area is 35 inches squared. So the trick in these problems is really kind of interpreting what the problem is saying. So I like to just skim through these really quickly and try to get a general idea of what we're looking for, and then go back through a little bit more carefully and set these equations up. So if you go to my screen, I'm going to write down, again, we said the height of a triangle is 4 inches more than 2 times the length of its base. And honestly, that's kind of hard to say, so it's a little tricky to read and interpret. But I like to just write this down slowly, piece by piece. So when we say the height of a triangle, we're going to say h is going to be our height, and b is going to be our base. So when I say the height of a triangle is 4 inches more, so I like to just think height equals, when we say is, I think equals. When we say 4 inches more, we're saying plus 4, then 2 times its base. So we can set this equation up. Height is 4 inches more than 2 times its base. And I, again, like to read the problem again and check my equation and make sure it makes sense. We also know the area of the equation. Area equals base times height. And in this problem, we're given a little bit of information that the area is actually 35. So I'm going to rewrite this equation over here as 35 equals the base times the height. Now again, we have 2 equations here, so we've got this equation that tells us the height, we've got this equation that tells us the area. So Again, with these problems, we have two variables and two separate equations, so we need to whittle that down to just one variable. So what I see here is I have an equation that gives us the height in terms of the base, so we can actually plug that back into our other equation right here. So all I'm doing is 35 equals the base, which I still don't know, times the height, which we've just said is equal to 2 times the base plus 4. And from here, we're just going to simplify and solve this. So 35 equals, we need to distribute this b to each term in the other expression. So b times 2b squared plus 4b. And from here, again, we have a quadratic equation. So we're going to set this up. If you remember zero product property, we actually need to set this up so it's equal to 0 because it's a quadratic. So we subtract 35 from each side. And we're left with 0 equals 2b squared plus 4b minus 35. And you have a couple options here for solving this quadratic. We can either use our zero product property and try to factor this, or we can use our quadratic. And off the top of my head, I'm not sure if we can factor this or not. I'm going to go ahead and use quadratic.
Quadratic formula.
Yeah, so quadratic is everybody's favorite. So the quadratic is b squared plus or minus square root. Oh, sorry, I messed that up, right? It's negative b.
Negative b.
Let's erase that. It's been a while since I've used this.
That's okay. I use it every day, which is why I know it.
Negative b plus or minus the square root of b squared minus 4ac, and all of this over 2a. And I know there's like a Pop Goes the Weasel song, but I'm not going to sing it.
There is. Negative b plus or minus square root of 4ac.
Exactly.
All over 2a.
Is that how it goes?
Yeah, something like that.
Yeah, so just
Probably
sing that
not.
to yourself a bunch of times and you'll remember it.
Yeah.
So in this quadratic equation, we have 3 variables now. We have a, b, and c. And if you remember, our form is ax squared plus bx plus c. So we're just trying to pull these variables out. So in this case, a is going to equal 2, b is going to equal 4, and c is going to equal a negative 35. And we come back to our messy kind of quadratic equation over here, and we plug all of this stuff in. So the tricky part here and the common mistakes I see are a lot of times related to the negatives. So what I like to do when I'm setting these up is put everything that I'm substituting in parentheses. So negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 2, and c, which is negative 35. And then all of this is over 2a, as Becca nicely sang for us. All right. So again, it looks really messy, but we just kind of walk through this using our order of operations. Negative 4 plus or minus the square root of 16 minus 8 times 35, which is 280. That's going to be plus 280.
Yep.
Right? Divided by 4. And I think I'm actually just going to stop here and break this down into 2 equations and do the rest in my calculator. Might be the easiest way to do this.
Yeah.
So when we look at these, when we look at quadratics, we really have 2 equations. So negative 4 plus square root of 296 divided by 4, and negative 4 minus square root of 296 divided by 4. So again, I'm just going to plug these both into my calculator and see which one makes sense. So let's see, negative 4 plus square root of 296, and then that's divided by 4. And for this, I get positive 3.3 approximately. I'm just rounding this. And the other one, negative 4 minus the square root of 296, and divide that by 4. So we get 2 answers here. One is positive, and one is negative. So mathematically, there are two possible options, but again, right now what we're talking about is the base. So when we talk about the base of a triangle, base, a length can't be negative. So that kind of eliminates this option here. So our base has to be approximately 3.3 inches. And now I don't remember, were we looking for the base or the height?
Good question. I don't remember.
Let's just pull that up again really quick.
We could find the height and the base.
Yeah, we actually need to find the height of the triangle,
okay, yeah.
so that works. So if our base is 3.3, we can go back to either one of these equations and solve for the height. And again, I always try to find the easier one. There's no need to make it more complicated. So we're going to look at this, and we're just going to plug in, now I know the base is approximately 3.3. We're just going to plug this back in, height equals 2 times 3.3 plus 4, and that's going to be 10.4. So that's our height. Again, the tricky part here is, if you know the quadratic formula, the tricky part really is kind of setting up both of these equations and then using that to find one equation that works. And then the quadratic formula, obviously, is always kind of complicated.
Beastly problem.
It was. Actually,
was
she
a
thought that was going to be a little quicker.
Yeah, it looked like a quick, easy one, but
Yeah,
that was a beastly problem. I
that's
see
why I
why
took
you
it.
needed help on it, for sure. All right, well, if you're just joining us, I'd like to give you our phone number one more time. You can call us until 5:30 today. The phone number is 720-424-1666. Give us a call with your homework questions before 5:30 today, and we can definitely get those answered. In the meantime, let's go back to Lily and get another question from social media answered.
Okay, so we have one question here, and it says x plus 1 and x plus 4 is greater than 0, and it says to solve for x.
Oh, okay, a little pre-calculus here, it looks like, I think. So in Algebra 2, if you are solving, that's one of the things that you do is you solve quadratics. So for example, in Algebra 2, you would do something like this, where you're finding out what x is whenever it's an equation. But this is an inequality. And an inequality, what you have to do is make sure you find the intervals that would make this equation true. So what I mean by finding the intervals is what range of x's would actually make this inequality true. So you can find the intervals are basically going to be defined by what x equals if this were an equation. So first we're going to find out what x equals if this were an actual equation, and then we're going to test some values to help tell us what intervals actually make this true. So what I'm going to do is set each one of these factors equal to 0 to find out what x actually is, or what it equals, and if this were an equation, and in this case it's -1, and in this case on this side it's 4. So what these numbers do is they tell us where our intervals are going to be split at. And what I mean by that, I'm going to draw a number line here real quick to show you exactly what I mean. So if I put -1 on a number line, it would be further to the left than 4. And essentially, numbers in either this interval here, from -infinity to -1, that might make this equation true. From -1 to 4 might also make it true, and 4 to infinity might make it true. And so we need to find the intervals of what make it true. So what we'll do is come up with test numbers, and it can be anything, but test numbers that are in between those intervals, so that we can test them and plug them into the equation and see, or the inequality, and see if they work. So I'm going to pick a couple here. I'm going to choose -2 for this interval because it's less than 1, -1. I'm going to pick 0 for this interval. 0 is an easy number to work with, which is why I pick it, but it's also in between -1 and 4. And then I'm going to choose 5 for this interval. Or actually, let's go with the number 10. 10's an easy one to work with. So we're going to plug in each of these values for x and see what happens if it makes this equation true. Now, since we have this inequality, I'm sorry, I keep saying equation, this inequality. Now, what we have here is greater than 0. So we're comparing our answers to 0. So all we need to know is if it makes the left side of this inequality, if it makes it positive or negative, and that'll tell us if it's either greater than 0 or less than 0, if it actually works. So we'll start with this -2. When I plug in -2 plus 1, and then -2 minus 4, you can do the quick math by just thinking, is this going to be positive or negative? So -2 plus 1, that's going to be a negative. And then -2 minus 4, it's also going to be a negative. And so then we're going to end up having a negative times a negative, which gives you a negative. So this, the -2, would actually not work in this scenario. Or sorry, a negative times a negative is a positive, my goodness, which would make it greater than 0. So in this scenario, this interval would actually work because it's going to make -2 or anything below -1 is going to make this inequality true. Now we'll test 0. So 0 plus 1, and then 0 minus 4, and we want to see if that would be greater than 0. So 0 plus 1, that's positive. 0 minus 4, that's negative. A positive times a negative is a negative, so that makes this not true. I'm also going to highlight this interval here that actually does work. So that one works. And then let's do the last one is 10. So we'll go 10 plus 1, and then 10 minus 4. We want to see if that is greater than 0. So 10 plus 1 gives you a positive number. 10 minus 4 gives you a positive number, and a positive times a positive is a positive. So this interval, and a positive number is greater than 0. So this interval works. It is greater than 0. So any of those numbers are going to make our inequality greater than 0. That being said, we need to write our answer in a way that actually says this. So we'll write it in interval notation. Everything less than -1 works. So what we would say is anything from -infinity all the way up to -1 is a solution to x. Nothing in between -1 and 4 is a solution. But then we also have an interval from 4 all the way up to infinity. That's another piece of our solution. So these right here are the intervals that make this inequality true. So there you have it. So this is a little pre-calculus for you. Hopefully, if this was your question, you had some background information on what I'm talking about. So if you're not at pre-calculus yet, don't stress if you don't understand what I'm saying, because it's higher level math. So hopefully that helps.
All right, we're going to take a second, make sure you have our contact information again. Our phone number, if you want to call in, is 720-424-1666. And if you look on our screen, there are a lot of other ways to contact us. You can go on Facebook at EG Homework, or Twitter, also at EG Homework. Or you can send us a text message at 970-680-3771. And you can also shoot us an email at homework@emilygriffith.edu. Probably the easiest way to contact us is just give us a call at 720-424-1666.
Yeah, call in those questions. It's free homework help for you. Yesterday, if you watched, you possibly got to see me interview a statistician.
Oh yeah, that was interesting.
Well, another one that we did, another real world apps, is I got to interview a fireman. So I found out if you are interested in being a fireman, what math is used in fighting fires. So check out this real world apps on the firefighter.
Hi, it's Becca. I'm with the Denver Fire Department Station Number 1, and we're doing real world apps for math. Hi, we're here today with Captain Pixley and firefighter Mako, and we're going to find out a little bit how their job works and how they use math in their jobs.
Well, I've been a firefighter with the Denver Fire Department for 22 years. We're a very busy engine company, and we work a lot with mathematics.
Firefighter Mako, could you tell us a little bit about what you do every day?
Yes. Well, I've been on the Denver Fire Department for 14 years now. At any time during the day today, I could be using math. Well, like today, I'm driving the engine, so that means this fire engine has a pump on it. So if we get a fire, I will have to know how much water to be pumping to whoever's on the hose line. And we do that by using different equations. And I may actually have to be pumping water through something like this big ladder truck behind you. So, and then there's other things, like when we pull up on a building, if we see the building maybe 20 by 40, you kind of have to have some idea of the size of building that we're dealing with, as far as how deep into this building we're going to go, how much fire we could potentially have.
So how is it that you use math in your job?
We use algebra when we pump our water through our hoses to make sure that we get a good fire stream, because we want to make sure we can get the water on the fire. And as Engineer Mako mentioned, sometimes we have to pump the water way high in the sky through either a ladder truck or through the air, and we want to make sure that we can get enough pressure behind that water to force it through the hose to get onto the fire itself. Not only are we using math for hydraulic equations, like I had mentioned, but also we'll use it to determine what the weight of a substance is, or what the weight of a material is, if there's a certain type of incident where maybe a building fell over or it started to collapse, and we want to know how much those particular components weigh, so we can factor that in as well.
Do you use any technology to help you with any of these math things that you do on your job, or any computers or calculators, or do you have to calculate it all on your own?
No, when we're on a fire scene, it's pretty much all left up to, like myself, I have to know how to put the numbers into the equation. So I don't really have a calculator with me or anything. It's pretty much just on the go type of thing.
Ooh, so learn your times tables, kids. What technologies do you use to do the math in your job?
Well, unfortunately, unlike Bobby, I have to use some simple tools, and I'll use a calculator quite frequently. But the important thing about mathematics is if you don't know what to enter into the calculator, you're not going to get the right formula.
This is true.
So I use a calculator a great deal, and I do use my computer. So luckily, in those respects, I'm able to get the right answer. Mm-hmm. But what Engineer Mako and I do is we have very commonplace formulas that we use. So we have pre-established the answers to those programs, and it helps us be faster on the fire ground. So what Bobby's showing you is a format, so we have already pre-calculated what the answers to the questions are. And we thought about the issues, or we thought about the mathematical problems that we use every day, and we already have an answer for them. So then Bobby will be able to look at that and have an answer immediately. He won't have to go to a calculator. He won't have to try to factor it into his mind. He'll know what he has to enter in to get to a quick answer.
Do you find yourself memorizing a lot of this?
Yes, I do. After a while, you remember some of the formulas, and I have them ingrained in my mind from my first company captains.
Hi, welcome back. We actually have a caller right now, so we're going to take that right now.
Good timing.
Yeah, I know. It really worked out. They called in during commercial, so. All right. Are you there? Hello?
Hi, my name is Timmy.
Hi, Kenny? Is that what you said?
Yes, Timmy. I have a question.
Okay, what's your question?
What is the degree measure of the angle formed by the hand of a clock at exactly 3:15?
Okay.
Sounds like a bit of a brain teaser.
It does sound like a brain teaser. That sounds really confusing. Because you would think 3:15 is 0, but then...
But it does move. The hand
that
moves a little bit with
moves
the hour.
a little bit.
Yeah, so you got to really kind of break down
Okay,
that.
so let's get a picture. That's what I'm going to start with. Let's get a graphic, a picture of a clock at 3:15, just so I don't have to draw it. All right, so if you cut to my screen, oh, I found one. Are you watching the show, by the way?
I am.
All right, so I'm going to pull up a graphic of this. Oops, this is the one I like. And we're going to put it, just regular paste. No, that's not what I wanted. Hang on one second. I'm sorry. I'm pulling up the graphic. Oops. Copy. Paste. Oh, there's my picture. Okay. All right, so. Oh. All right, so where I was getting at, and this is a very small picture. I can't really make it any larger. Okay, caller, are you still there?
I am.
Okay, great. So kind of a fuzzy picture I've got going here, but what I would like to kind of point out here is, so the minute hand is at exactly the 3, and then the hour hand is a little bit past the 3. And part of what we're going to need to know in order to answer this question is how much past the 3 is. And so what you would assume is that hour hand moves closer to the 4 proportionally to what the minute hand moves. So right now, basically your minute hand has moved a fourth of the way around, or a fourth of the hour. And so you could assume that on its way to the 4, it's just a fourth of the way to the 4. And so if we knew what the angle was in between each hour, we could take a fourth of that and then find the angle of the minute hand and the hour hand. So what we know is that in a circle, there are 360 degrees in the whole clock, the whole circle. And then we know that there are 12 hours in the whole circle, so we can divide this 360 divided by 12 to find out what the angle is for each hour. And what we get with that is 30 degrees. Does that make sense so far?
It does.
Okay, so we have 30 degrees between each hour, and we know that when it's at 3:15, it's going to be a fourth of the way through that 30 degrees. So we just need to find a fourth of 30 degrees. So to do that, we can just take 30 divided by 4 to find a fourth of it, and you end up getting 7.5. So 7.5 degrees is what it should be from between the minute hand and the, my face is covering it. So 7.5 degrees between the hour hand and the minute hand. Does that make sense?
Yeah. Huh.
Okay. Yeah, it's just kind of thinking of, well, what do you have total? How can I possibly figure out, the difference between where it is and where it was, and just breaking it down.
That was easy.
Great. Okay. Well, I'm glad I could help. Is there anything else you had?
No.
Great. Awesome. Well, thank you so much for calling. Appreciate it.
So I think we're going to toss it back to Lily for another social media question.
Sounds good.
Okay, so she has a question that says, the radius of a circle is 3 centimeters, and what is the circle's circumference?
Okay, so another geometry question. And again, we really got to think about, this comes down to just knowing the equation of a circumference. So the radius of a circle is 3 centimeters. What is the circumference? So I'm going to take a second, write that down, and draw a quick picture of a circle. It's not going to be as nice as the picture you copied. So when we look at the circumference, first of all, just think about like what the circumference is and what the radius is. And radius, remember, is just the distance from the center to the outside of the circle. And circumference is the distance around the entire circle. So if you think about it like this, if I were to stand right here, like this is me, and I walked around this entire circle, when we're asking about the circumference, we're trying to ask, how far around is that circle, to get back to where you started. So if you remember, the circumference of a circle is this equation, 2 pi r. And the information given to us was the radius. So I know that the radius of this circle is 3 centimeters. And we want to find, again, the distance around the circle. So all we're really doing is evaluating this. So circumference equals 2 times pi times the radius, which is given to you, 3. And we're just going to simplify this from here. Circumference is 6 pi. So again, with these problems, you could say the circumference is 6 pi if you're thinking about it, I don't know, in terms of real life application. If I were walking around this circle, I would probably never say that the distance around is 6 pi. So thinking about like the application of it. In this case, if I were trying to find the distance, I would actually just go ahead and calculate 6 times pi. And you get approximately 18.8496 centimeters. This again is approximate, so depending on the homework assignment or kind of what the goal of this is, if I were actually trying to find a distance, I would probably actually calculate this so it made a little bit more sense. But if I wanted to be more precise, it's always going to be more precise if I don't use my calculator and I don't do any rounding and I just kind of leave it as 6 pi. So hopefully that helped.
All right, I think we're going to go back to Lily for another social media question. So let's get some more answered.
All right, so he needs help changing this percent to a decimal, and the percent is 120%.
Okay.
Do you want to take that one?
Sure.
Okay.
I will do that. If you just cut to my screen, I'll show you how to do it. So 120%, when we're turning it to a decimal, well, let me actually break down what percent means. So percent, and you can actually kind of think of them as separate words. So per meaning out of or division, and then cent, that's kind of a prefix, usually a prefix, but cent means out of 100, or sorry, cent is a prefix that means 100. And so 120% basically means 120 out of 100. So one way to do this is to do 120 divided by 100. When you divide by 100, what ends up happening is your decimal point ends up moving 2 decimal places to the left, so like this, and would end up getting 1.20. So just thinking about what percent means can help you actually get to your answer, turn percents to decimals and vice versa. So hopefully that helps.
Yeah, it's always helpful to think of like a percent as out of 100 whenever you're doing these problems. I think that's
it helps a lot whenever you really can kind of, like, for example, if you did, I don't know, if you were thinking of 25% or 50%, 50 out of every 100, let's say you had to find 50% of 400, you're just doing 50 for every 100 that there is.
Right.
So it really is helpful to think about it that way. But
I think are we going to do another social media question?
One more social media question.
Right.
I think we can squeeze one in.
Okay, so this one says a square has an area of 16 square centimeters. What is the length of each of its sides?
All right, I think I can take that one. Another geometry question. So we're saying a square has an area of 16 centimeters. So this one you really kind of have to think about like the properties of a square. And you should know that, if I have a side, we'll call the side length S. When we talk about a square, all of our sides are going to be the same. So this side's going to be the same as this side. So if we talk about like the area of a square is going to be the side length times the other side length. So here we know that the area is 16 square centimeters. Well, if we know that, we can plug that into our equation. So we get 16 equals S times S. And we want to simplify this a little further to solve for S. So 16 equals S squared. So right here, we need to actually think about our inverse operations. So when we're squaring something, we need to, again, think of like, what can we do to undo this operation where this is squared? So if we think about what the opposite of squaring something is, well, that's going to be the square root. So we'll take the square root of each side. And again, it's the inverse, so that's going to kind of cancel out that operation where we were squaring. So the square root of s squared is s, and the square root of 16 is 4. And actually, this is going to be plus or minus 4, because if you kind of think back into the equation, when we're squaring something, whether it's positive or negative, it's going to end up being positive. So again, mathematically, the answer could be plus or minus 4, but if you think about the application of the problem, well, we can't have a square with a negative side length, so the negative is not possible. So we're going to have a side length of 4. So every side on this square is going to be a length of 4.
That'll also give you a perimeter of 16 as well.
Oh, you're right, it would.
It's
Just a fun
special
math
square.
fact.
Oh, yeah. So, well, we're going to take a little break, and you're going to get to hear, lucky you, a little bit of information about Emily Griffith High School and Emily Griffith Technical College. There are some really cool places. If you haven't heard from them, you really should. So.
And also, when we get back from the break, we're going to be talking about our Facebook discussion on 3D printing.
Woohoo! See you soon.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Welcome to Nerd Necessities Network. You're probably thinking, what is Nerd Necessities Network? That's a good question. Nerd Necessities Network is a premier DPS TV show all about nerdy people, places, and things. Check us out on Facebook and YouTube and all the social networks. That's a wrap!
Welcome back. As Lily mentioned earlier, we're going to start our Facebook conversation right now.
So right now we were talking about a rescued Brazilian toucan that gets a new 3D printed beak. And this toucan was rescued by Brazilian rescuers after it was found obviously mistreated. And so the toucan couldn't eat and couldn't clean his feathers properly. And so they made I think it took about a couple months to make the beak for him, but it only took him 3 days it took it a couple months to design and print it, but it only took him 3 days to basically get used to having a beak again. So yeah, it's a pretty cool article.
That is really cool. I've been hearing a lot about 3D printing lately, just all the different uses, and it's becoming a lot more common. I actually didn't know that 3D printing started in like 1986 from a guy named, it was invented by a guy named Chuck Hull. But I didn't realize it's kind of been around for so long, because now it's really starting to kind of catch on. You're seeing a lot of 3D printers.
I can't even imagine how expensive it would have been back in 1986.
Oh, yeah.
Even computers, personal computers, were so expensive back then, and not very compact. Back in '86 for sure. So the way that they work actually is with what's called G-code, and G-code, what it does is it tells an object how to move, in which direction to move. So this G-code is basically telling the 3D printer where to deposit the material.
It's probably got to be on several different axes, right?
Yeah, 3D. So you've got multiple axes because of it. Yeah, it's not just X and Y moving left and right. It's left, right, up, down. So hence 3D. Yeah, absolutely. So I don't know, there's definitely a lot of applications of 3D printing. I mean, you can think of, like we were talking about, prosthetics, potentially.
Yeah, I actually saw they were 3D printing a house, I think
That
last
is so
year. So they just had a
cool.
giant 3D printer. And I don't know, scalability, eventually, I could see that kind of catching on. But yeah, I think.
Absolutely. All right, well, 3D printing, very interesting. So if you are interested in that, we do have that article on Facebook, so check it out if you get a chance. Let's go answer some more questions back at social media. So what do you have for us, Lily?
Okay, so he asked, how do you convert 17 yards into inches?
Okay, conversion. I can take this one.
All right.
We could fight over it if you want, but.
No, I think I'm good.
All right. All right, so we have 17 yards, and we want to convert them into inches. Now, the thing that we want to make sure that we're doing when we're doing conversions is we need to know the conversion rate. So we need to know how many feet possibly are in a yard. So 1 yard is equal to 1 foot. And then we also, since we're going to inches, we need to know how many inches are in a foot. So 12 inches. So we're going to use these conversion rates to help us. I'm going to move this over so I have more space here. So 17 yards. And then we're going to first convert it into feet. And so what we'll do to do that is multiply. So we know that there is 1 foot in, sorry, my goodness, my brain is not working here. 1 yard is 3 feet. Wow, I'm surprised, Nate, you just let me do that. You just let me say a yard equals a foot. My brain's not working. All right, so 1 yard, I caught it though. So 1 yard is 1 foot. So we'll say 1 foot per 3 feet. Oh my goodness. Hang on a minute here. So 3 feet are in 1 yard. There we go. So 3 feet per 1 yard. And so this is going to essentially, and if you saw our show yesterday, I was showing how we did unit analysis, where we use these units and they cancel each other out because it's yards over yards. Anything over itself just equals 1, and multiplying by 1 does not change our value. So now we have successfully converted into feet. So 17 times 3, I'm just going to 51. So 51 feet. I'm having issues here. So 51 feet are in 17 yards. Now we need to convert to inches. So we're going to do a similar thing. We're going to say 12 inches per 1 foot. For 1 foot. So foot and feet, same thing. Those cross out, and we just do the multiplication. So we'll do, and I'm going to use my calculator for quickness, but we'll do 51 times 12, and you end up getting 612 inches. And that is 612 inches in 17 yards. So conversion rates, we can use that unit analysis, and all we need in order to do that is what are our conversion rates? So there you have it.
All right, I think we're going to toss it back to Lily to go over the trivia question.
All right, so the trivia question, once again, is what are the chances that in a room with 75 people, that at least 2 of them will share a birthday?
So if you give us a call in at 720-424-1666, remember you can always win a prize if you get the answer right. And feel free to guess.
Very true. Feel free to guess, yeah.
Yeah, it doesn't
hurt. Feel free to guess. If you don't have it, if you don't have an idea what it is, feel free to guess. But what I hear right now is that we have a caller, so let's go ahead and take that. Hello, are you there?
Here.
Hi, thanks for calling Homework Hotline.
Hi.
Hi, what's your question?
Well, first of all, I saw the trivia question, and I'm going to guess that it's 25%.
Oh, good guess.
It's a good guess, but I
Not
think it's a
the
little low,
answer, though.
actually.
What?
All right.
It's a little low, actually, at 25%.
Yeah, a little bit low. So there's a clue. Now you guys have clues. But hey, thanks for guessing on that one.
All right.
Might as well.
I'm calling for my daughter's homework, actually. I'm supposed to be helping her with her math homework.
Okay.
And I haven't done this kind of math in a very long time.
Understood.
Pretty much don't remember anything.
Totally
That's
understood.
fair.
Yeah.
So here's the question. It says, if a triangle has two angles, 45 degrees and 90 degrees, what is the measure of the missing angle?
I can take that one since that's a geometry question. So I'm actually just drawing this out. And again, are you watching right now?
I am watching.
Okay, so you should be able to see this. So I have a right triangle because you said it has an angle of 90 degrees.
Correct.
The other one's 45 degrees. Do you happen to remember from way back when how much all the angles of a triangle add up to?
They have to add up to 180 if I remember right.
Yeah, so that's a clue right there. So we're trying to figure out this angle measurement right here, and we can just call it X, you can call it B, whatever you want. But what we know is all three of these have to add up to 180 degrees. So this, and this. So all we're going to do then is go ahead and set up an equation. So we're saying we have an angle that's 90 degrees. We have another angle that's 45 degrees. And we have another angle that we don't quite know yet. But like you just said, these all have to add up to 180 degrees. So does this look a little bit familiar to you?
A little bit, and now that you're setting it up,
Yeah.
it looks like it's an easier problem than I thought.
Okay, so this comes out to be just kind of a straightforward equation if you just remember some of the properties of a triangle and how to set that up. So we're just going to combine our like terms. 135 degrees plus x has to equal 180 degrees. And from here, we're just isolating the x, solving for x. So we're going to keep our equation balanced. I'm going to move this over by subtracting. We'll do the same side, same thing to the other side. And you'll get a measurement of 45 degrees.
Okay, that makes sense.
Right,
Well, I actually wrote down the steps because, to be quite frank, I didn't remember how to set it up.
Oh,
And
okay.
my daughter has to set it up properly. She can't even just say the answer.
Oh, yeah, and as a math teacher, we like to see that our students actually know what they're doing. It didn't just, ask their parent for the answer and then.
Show your work. Show your work. Or just ask Homework Hotline for the answer. You actually
Yeah, that
have
works
to
too.
show that you listen to us, right?
Right.
For sure.
All right, well, thank you so much, you guys, and I will look really smart in front of my daughter, and that will make me a champion. So I am a superhero today. Thank you so much.
Great.
Glad we could help.
Thank you
Thanks
so
for
much for calling. Call us again if you need to.
All right.
All right.
Bye.
Take care. Awesome. All right, let's go back to Lily. Since we don't have any callers, we'll at the moment we'll go back and we will get some social media questions answered.
Okay, so we have an inequality problem, and it says how to solve this, and it's 12 is less than x plus 5.
Another inequality. You want to take this one?
Sure, I'll do this one. This
cranking
was
those out.
much easier of an inequality than the one that we did earlier. Not any pre-calculus here. This is more algebra. So it says 12 is less than x plus 5. And what we have to do is we have to isolate x. Thankfully, with linear inequalities, inequalities that are going to just give you one solution, they work just like equations. So we can just do the balancing thing that we do where we are just isolating x and we're just doing the same thing to both sides of our inequality. So to isolate the x, we're going to undo this plus 5 by subtracting 5. And we also have to do that to both sides. So then we have 12 minus 5, which gives us 7, is less than x. So when you're solving these, you're not going to get one answer. You basically get an interval. So anything, and I'm actually going to even write this another way just to kind of show you it. We can also switch up our inequality, so switch the order of it. So we could even say that x is greater than 7. And that actually, for me at least, makes a little bit more sense in my brain. I know that whatever x is, it is larger than 7. So there you have it, inequality solved.
Yeah, I think it's helpful to just remind everybody that just because it's an inequality doesn't mean you do anything different than when you're solving an equation.
Yeah, it's really not different. The only different thing, though, that always used to catch me is when you multiply and divide by a negative number.
Oh, to change the sign.
You've got to change the sign.
Yeah,
That's the only, though, difference, really, when you're solving the inequalities than equations. They really do work the same. But everybody looks at them and they say, oh, what?
Right.
Don't know how to do that because it has a different symbol, but really same steps.
So I think we're going to toss it back to Lily for another social media question.
All right.
So it says when b equals 6, a equals 42, what is the value of a when b equals 9?
That could actually, there's not necessarily enough information at that problem. There could be two answers.
So I think this is kind of a direct variation problem where we have a relationship. So we say when b is 6, a is 42. What's the relationship between b and a?
I mean, but it could have two different relationships is what I'm saying. So it could be addition, which wouldn't be direct variation. But still, I mean, they didn't say that it was a direct variation.
You could be adding 36 or you could be doing something else.
Okay. So here's where I'm going to go with this. So, and I'll explain it both ways. So maybe you might have more information about what you're looking for. But so then they're kind of saying, okay, well, B is 6, A is 42. And then if B is 9, what is A? What we're trying to think of, though, is if we have B, what would we do to it to get A? One of the ways, and probably the one that is what you're looking for, is that to get A from B is we could take A times 7, and that will give you, or sorry, B times 7, and that would give you A. So 6 times 7 would give you 42. So if we applied that same rule to the next B, 9 times 7, that would make A 63. So this is, I think, what Nate was
Yeah, and I think the key thing there is typically in these problems, and maybe there's something missing, but typically I'm guessing what was meant here was if they said B varies directly with A, then that would be exactly what you're doing.
And that's likely what it is. Just in case, though, I'll give my other kind of reasoning of why I was saying that this might be something else, is the other way that we could get A from B is we could add, and we could say 6 plus, and then it would be what 36 would give you 42. So if you applied that same idea to the 9, then B would be something different, which would be 45. So that's also possible, but like Nate said, the one that we talked up here, this is probably the most likely. Just knowing math and math curriculum, I would assume that that is it, and there was just a little bit of information missing from that question. So if I did not answer your question, or if you have more information to provide, go ahead and call us or let us know. Just email us or whatever you did, and we can help you.
All right. I think we're gonna
trivia time.
Hop back over to Lily for trivia.
Trivia time. So we did have a guess, not a correct one, but awesome attempt. So no prizes today, but let's get our answer for this trivia question.
Okay, so the question one more time was, what are the chances that in a room with 75 people that at least 2 of them will share a birthday? And that was 99%.
I like it.
Wow, that's a lot higher than I would have thought. I think people's initial reaction is it's like 75 out of like 365. Which would probably be kind of close to that 25% that the caller guessed.
Out of 365, be like 21%.
So pretty close to the 25% guess. I think there's that logic right there.
Right.
These are all actually kind of interesting. I was looking at this, and apparently if you have 23 people, there's like almost a 50-50 chance of people having the same birthday.
Yeah, I mean, and that's almost as big as a classroom.
Yeah.
So you think about that, and it's, okay, in one classroom, there's a 50% chance, which is pretty high, that two people would have the same birthday.
It's funny because I'm always surprised when two students have the same birthday. But
Whoa, what are the
I've never
odds?
met anybody with
pretty
my
likely.
birthday.
So, and actually the math with this, and I'm going to kind of pull up really quickly how difficult this is to figure out. I'm not going to explain entirely how to do this, but what did we say? It was the birthday?
It's like the birthday paradox problem.
Still. Birthday paradox.
It's actually a lot more complicated than it sounds in terms of probability and statistics. But interestingly, it kind of, all the math, kind of all the probabilities kind of compound. So that's why when you have 75 people, it's like a 99% chance. It just kind of compounds really quickly to increase the chances of that.
Yes, so it does. It really, and you can actually see with that image, that graph that was given, and I'll pull it up to that graph that was given with the answer. You can see how quickly it increases. There we go. How quickly it increases the probability the more people that you end up having. So actually on that one, and you can barely see it, but it shows you the 23 people where
and that's about
it's
50%.
Exactly. Yeah. It does. It shows you that. But the math is very difficult. It's kind of upper level prob and stat. It's a combination problem. So if you look on my screen, I have the Wikipedia, shown up here. And actually, you can look this up on Khan Academy too. But the explanation, it's about, what'd you say, like
15
a 15-minute explanation?
And it's pretty in-depth.
So it is. It's definitely not an easy prob stat problem to be able to explain in a succinct, small amount of time.
Yeah, we're in layman's terms. It'd be difficult to just kind of explain.
Yeah, you'd have to know a little bit of probability to be able to understand. But yeah, it is. It does though. This graph really helps a lot understand where that's coming from and where that probability comes from. So,
do you share any birthdays with anybody in particular that?
Well, I have, so my birthday is 11/11, which I love because it's a numbers thing.
Easy to remember.
That's my grandparents' anniversary.
Well, there we go. See,
yeah.
Yep.
I always remember it because my
right?
parents are 7/11 and my grandparents are 11/11. So
oh, there you go.
Like,
oh, yeah.
I used to date
11.
someone, their birthday was 7/11,
yeah.
and it was kind of like, oh,
Do we,
free
any of us have the
Slurpees
same
on that
birthday?
day.
When's your birthday?
Mine's July 24th.
Nope.
No?
Nope.
December 4th.
Well, that's still a pretty low probability, I guess.
But Leonardo DiCaprio has my birthday.
Oh, yeah?
Mm-hmm.
I think my birthday was the day that Prohibition actually stopped.
Oh,
I believe that's
what is that called? Prohibition Day? Really? Is
yeah,
it called that?
yeah, I believe so. I heard Mr. Wall told me that last
there's
year.
a day.
I was like, oh, all right, well,
Okay.
awesome.
I don't know.
But I've never met anybody with my birthday ever. I've met somebody with like a birthday before mine or the day
When's your
after.
birthday again?
December 4th.
Do you have any famous people?
I think like oh, who is it? I think I share a birthday with, I want to say Neil Tyson.
Neil deGrasse Tyson?
Yeah,
Oh, that's a good one.
I feel like I
that is a
share
good
a
one.
birthday with him. I'm not sure though. Might be my brother that shares a birthday with him, but I'm not sure.
I always
think
do
I do.
because
If I
you're
do,
watching
then
TV and
that'd
they're
be
like,
awesome.
oh, it's these people's birthdays. And I'm
Right.
like, well, it's
Whose
also my
birthday is it
birthday.
today? Ta-da. I think I also have, Demi Moore and Callista Flockhart. Is that it? Callista Flockhart?
Oh, yeah, it is actually. Or do you know who?
So you can always look it up. I'm sure you can find that information online. It's kind of interesting to know that, if anything.
Yeah.
However, we've got to say goodbye, unfortunately. So tune in to see us next week. Again, same time, same place, Tuesdays and Wednesdays from 4:30 to 5:30. Get all of your homework questions answered for free, and also answer a trivia question and win a prize. So all kinds of great things.
Yeah, you can also get on live stream if you want to watch us on your phones.
True, also. Bye, thank you.
Bye.